So basically, we're going to be learning about solving all different type of equations. So the first example is on solving linear equation, which is the easiest one, I would say. Linear equation. So it's basically just isolating the variable and solving. So it's 3x minus 6 is equal to 0. How would you solve? So isolate the variable. Keep in mind, first we get rid of the number that's being added, subtracted. So I would add 6. And then we divide or multiply. So it's going to be, I'm just going to quickly go over this. So basically it's going to be 6 divided by 3, which is equal to 2. What I did, I added 6 and divided by 3 later on, so that's my answer. That's how we solve linear equations. Now next one, I have fractional or rational equations. So let's say you have rational equations. Okay, so I'm going to show you two different examples, or how about if I show you the hard one? Yeah, let's do that. So I have 1 over x minus 2 is equal to 3 over x plus 2, 6 over x squared minus 4. Okay, I don't know if you remember, last semester we did something like LCD method. So in order to solve these kind of fractional or rational equations, LCD method works way easier than any other one. So what we do is, first you have to have LCD of all the denominators. But it's better to simplify each denominator first. So this is already kind of simplified. This is also simplified. But this one can be simplified because I see it's a difference of 2 perfect square. So I could factor this out as x minus 2 and x plus 2. Now LCD, so I don't know if you need help, I can actually do it, but pretty much like I'm just going to skip that part. So LCD is basically getting all those kind of factors you see in the denominator. So I see x minus 2 and x plus 2, two different types. So basically both of those going to be my LCD. So x minus 2 and x plus 2 would be my LCD. Okay, once you get LCD from all the denominators, next is you just have to multiply both sides by that LCD. So x minus 2 times it by x plus 2. Same thing on this side. So basically multiplying each fraction by that. So x minus 2, x plus 2, x minus 2, and x plus 2. Okay, if I simplify the left side, so you know x minus 2 is going to get canceled out. So what's left? I have x plus 2 left on the left side. Let's move on to second fraction. So you know x plus 2 is going to get canceled out with x plus 2. So what's left is 3 times x minus 2. There's a minus. Now, okay, isn't it x squared minus 4 is same as x minus 2 and x plus 2? So basically, this is going to get canceled out with both of these factors. So what's left is just 6x. Next, this looks like kind of way easier than before. So now pretty much you just have to distribute, combine like terms, and solve. So distribute this 3x minus 6 minus 6x. Combine like terms, I have x plus 2. So you know 3x minus 6x, x is on the same side. I would just follow the sign. So 3x minus 6x would be 3x minus 6. So I would add 3x both sides. Why? Because it's easier to keep variable on the left side and numbers on the other side. So this becomes 4x. 2 is going to get canceled out. So this is 8, negative 8, and x is equal to 2. Now, I already got my answer, but now it's the time to check. So we check for extraneous solutions. There's a shortcut, but there's a long way. So long way is like you can literally take this number, plug it into the original equation, see if both sides are equal or not. Here's the shortcut, because I know not everybody's going to be a fan of long way. So here's something you could do. Remember, if it's a fractional function, you always have to watch out for excluded value. Remember, excluded value is something that makes the denominator 0. If I just ask you, literally look at the original problem. Is there any excluded value for this big equation? Think about it. So if I look at it, I feel like 2 and negative 2 is going to be my excluded value. And at the end, if your actual answer has any of the excluded values, you already have it up there. So that cannot be your answer, because technically that solution would make original function undefined. So just cross that out. But let's say if something other than excluded value, yeah, we would still consider that as our final answer. So that's how we solve rational function. Now next I have quadratic functions. How do we solve quadratic functions? I don't know if you remember, there are multiple ways you could do. So you can do it by quadratic formula. You could do it by factoring. You could do it by taking square roots. That's another one. Square roots. Can't think. Oh yeah, completing the square. That's another one. I know nobody actually likes that, but that's just, yeah, completing the square. That's where you get the magical number, you complete the square, right? Anyways, I'm going to show you one example on each. I'll try. So here comes the first one. Let's say I have 2x to the second plus 9x plus 7, and it's equal to 3. First thing, always make sure equation has to be equal to 0. So it's not equal to 0, so first you have to simplify that. 2x to the second, 9x, and it's equal to 4. I'm sorry, plus 4, and it's equal to 0. The rest is pretty much, okay, if you're doing by x factoring, if you're solving this by x factoring, so again, you really needed to know that first. So x factoring is, this is how we do x factoring. We do AC. I'll just do a quick review for you. A, C, and B down here. So A, which is 2, C, which is 4, multiplied together makes 8. B is always the middle number, which is 9. Find me two numbers, multiply to 8 and add it to 9. So I would say it's 8 and 1. And remember, if A is other than 1, so we divide by that A value. Try simplifying. The first one would be x plus 4. Second one, the one you can simplify, just put x with the bottom number. 2x plus 1. All right. That's not all. We are solving, so it means you have to find an answer for x. You actually have to solve for x. So how do we do it? So pretty much you just have to set each factor equal to 0 and solve each one. So x would be equal to negative 4, and this x would be equal to negative 1/2. I'm just going to do one more example, and yeah, that's going to be all for today. So let's say I have something like this. 4x to the second is equal to 12. All right. You could do x factoring if you want it, and then try to make it everything equal to 0 and then x factor. But there's another way, which is way easier than that. What is that? It's called taking square root. So here's, again, first thing, you have to isolate the variable. So you need to isolate the variable. How would you isolate that? So pretty much I would divide both sides by 4. So this becomes x squared, and it's equal to 3. Now, some of you guys might gonna say, why can't you take square root at the first place? You cannot, because that square goes with just x, not the whole thing. If it goes with the whole thing, yeah, you can actually take square root to the whole thing and then get rid of that. Okay, but since that square goes with just x, so that's the reason I have to isolate the variable first. Once I have that, so now I can just do inverse operation. I would do square root both sides. Square root's going to cancel the square. I have x is equal to. I hope you understand. If you take square root, what do we need? I hope you remember that. Plus and minus square root of 3. And there's exact same topic, but just an example on that. I have x minus 3 and square, and there's 7. Okay. Can I do square root right away, or do I need to isolate the variable? No, I would take square root right away. Why? Because that square goes with the whole thing. So I could just do that. cancel the square. So I have x minus 3 square root. Don't forget plus and minus 7. And lastly, I'll just isolate the x or the variable. So I would add 3 both sides. So finally, my answer is going to be this. You can simplify more if you want it, or just leave it like this. It's the same thing. Thank you for watching.